Okay, now we're going to do number 3 on the back of the review sheet. It says, in a wild shoot, Bo shoots a pool ball of mass M off a .68 meter high pool table. So I know some height is 0.68 meters. And the ball hits the floor with a speed of 6 meters per second. So some speed is 6 meters per second. How fast was the ball moving when it left the pool table? So this is VF. I want to find VI. Okay. And that's it. So it says to use conservation of energy. Now, whenever you're doing conservation of energy, if you draw a little picture in a diagram, it's going to help you to visualize what's going on. Okay? Now, if you remember when we did projectile motion, so let's just picture that the ball falls off the pool table, and let's not even worry with it being a projectile going like this. So let's just say that the ball is going to start off up here, and it's going to end up down here. So here we know that we want to find the initial velocity. We have this height, and when it hits the ground, which is called base level, that's our frame of reference. So the key here is this height is 0.68, and here the height is 0. So now I know that this is HI, and I know that HF is 0, and now I have all my information. So when I do conservation of energy, I'm going to say that the total energy before is equal to the total energy after. Now, you don't have to write that down, but I'm just trying to show you conceptually what conservation of energy means. So the total energy before is a sum of the kinetic plus the potential. So KEI plus PEI is equal to KEF plus PEF. Now, before I start plugging in stuff, it makes it simpler if I know, well, is anything 0 on this problem? So because I see that the final height is 0, and I know potential energy is mgh, this goes to 0. But that's the only thing that's 0, because HF is 0. So now I'll start substituting in. So it's 1/2 mvi squared plus mghi is equal to 1/2 mvf squared. Now I want to solve for vi. So when I want to solve for something like this, I need to put it in the numerator all by itself on one side of the equal sign. So now it's just algebra. Now if I want, to make it easier, I could cancel the m, so I have one less variable, plus I don't think they gave me the mass. Okay. Now normally I would multiply everything by 2 because it might make it easier. So if I multiplied everything by 2 to get rid of the 1/2, then I would have vi squared plus 2ghi is equal to vf squared. Because you notice when you multiply everything by 2, 2 times 1/2 is 1. Okay. So now I want to solve for vi, so I need to put that on the other side of the equal sign. So vi squared is equal to vf squared minus 2ghi, but I want to solve for vi. So the most common mistake people are going to make is they're going to forget to take the square root at the end. So I'm going to go ahead and do that now and say vi is equal to the square root of vf squared minus 2ghi. So now I'm going to substitute in my values. So VF is 6 squared minus 2 times 9.8 times 0.68. And remember, that's underneath a radical. So this is if I did on my calculator, 0.68 times 9.8 times 2 is equal to 13. But there's a negative sign, plus 36, because that's 6 squared. And then I have to take the square root, and that comes out to be 4.76, so it's about 4.8 meters per second. And that's it. And that's the problem. So again, this is the conservation of energy problems, again, you write it all out, and then you see is anything zero, because we've done different types of problems.